Hello, Math 1 students. This is Mr. Liao, and this is 10.2 Parallel Lines and Transversals. I'm going to be recording videos, so as long as we're doing this distance learning thing, with the videos, you can start and stop whenever you want. You need to go back, you need to pause, do what you need to do. I'm going to just keep on going. If you need to go back, you don't have to wait for me, you don't have to raise your hand. Just stop, go back, and see what you missed. Our objectives are to learn to use the properties of parallel lines as well as proving theorems about parallel lines. If you recall from section 10.1, a transversal is a line that intersects two or more other lines. So here, line T is the transversal. It intersects both lines P and Q. Now, two parallel lines are cut by a transversal. There are special relationships between the four different types of angle pairs that we learned in section 10.1. They're going to either be congruent, in other words, the angles are going to be the same measure, or they're going to be supplementary. In other words, the angles add up to 180 degrees. Now, the diagram will often tell you whether angle pairs are congruent or supplementary. For example, angles 1 and 5 are corresponding angles. You can tell they're both obtuse, so they're probably congruent. On the other hand, we have angles 3 and angle 5. One is acute, one is obtuse. They are consecutive interior angles, so since they're not the same type of angle, they're probably supplementary. So that's one way to help remember how the angle pairs are related, just by looking at the shapes of the angles. So let's start with the corresponding angles theorem. Corresponding angles are in the same position for where the transversal intersects the lines. For example, 1 and 5 are congruent because they are corresponding angles. They're both in the top left. Angles 2 and 6 are congruent, both in the top right. 3 and 7, both in the bottom left. 4 and 8 are both in the bottom right. So corresponding angles are congruent. Alternate interior angles, remember they are both inside the two lines intersected by the transversal, but they're on opposite sides. Alternate interior angles are also congruent. So angles 3 and 6 and angles 4 and 5 are congruent. Alternate interior angles. You can tell by the shape 3 and 6 are both acute, 4 and 5 are both obtuse. Next, we have the alternate exterior angles theorem. So these are outside the transversal, but they are also congruent. So angles 1 and 8 and angles 2 and 7 are congruent. Notice 2 and 7 are both acute, 1 and 8 are both obtuse. So alternate exterior angles are congruent. Remember, this is only true if the two lines that the transversal intersect are parallel. Finally, consecutive interior angles or same side interior angles. Same side or consecutive interior angles are supplementary, again, if the two lines that the transversal intersects are parallel. So angles 3 and 5 add up to 180. They're supplementary. Angles 4 and 6, they're same side interior or consecutive interior angles. They are also supplementary. Their measures add up to 180. Notice that 4 and 6, 4 is obtuse, 6 is acute. They can't be congruent, so they're probably supplementary. Example 1. The measures of three of the numbered angles are 120 degrees. Identify the angles and explain your reasoning. So let's call this first angle angle 1, just so I can identify it by a number. So which angles are also 120 degrees? Which angles are congruent to angle 1? So we have angle 4, because angles 1 and angles 4 are vertical angles. Remember, vertical angles are angles across from each other when two lines intersect. So they are congruent, so angle 4 is also 120 degrees. We also have angles 1 and 5. Angles 1 and 5 are corresponding angles. Remember, they're both on the top left where the transversal intersects the two parallel lines. So they're also congruent. Notice that both of those angles are also obtuse angles, so they're going to be congruent. Finally, we have angles 1 and angles 8 congruent because those are alternate exterior angles. Notice 1 and 8 are both obtuse angles. And again, when you have a transversal intersecting two parallel lines, you can just look at the diagram and you can tell which angles are related. Now, you'll also need to know the relationship between the angles, but that'll help you remember at least which ones are congruent. So now we're going to find the measures of the remaining angles. So angles 2 and 3 are both 60 degrees because they're linear pairs. So those are a linear pair right there. And angles 1 and 3 are also a linear pair. Let me put that a 1 there again so you know that's an angle 1. Also, angle 6 is also 60 degrees because angles 2 and angle 6 are corresponding angles. They're both top right angles, so they're congruent based on the corresponding angles theorem. Angle 7 is also 60 degrees because you know angle 2 is 60 degrees. Angles 2 and 7 are alternate interior angles, so they're also congruent. Notice both of those angles are acute as well. Now, extra example 1. Find the measures of all the missing angles and explain your reasoning. So I'm going to call this angle, angle 3. That's a 75-degree angle, and we're going to try to find the measures of all the missing angles, 1, 2, 3, 4, 5, 6, 7, 8, but not just that, explaining why those angles are what they are. And on the test, it's not just finding the measures of the angles, you're going to have to explain why they are either congruent or supplementary. So angle 3 and angle 2 are vertical angles. Vertical angles are congruent, so measure of angle 2 is also 75 degrees. Angle 1 and angle 4 are both 105 degrees because they are in a linear pair with angle 3. So there's angle 1 and angle 3, so angle 1 has to be 180 minus 75 or 105. Likewise with angle 4, it is also 180 minus 75 or 105 because remember, angles that form a linear pair are supplementary. So that's why those two angles are supplementary. Angle 5 has to be 105 degrees because you know that angle 4 is 105 degrees because it's in linear pair with angle 3. Angle 5 is congruent to angle 4 because they are alternate interior angles. Since angle 5 is 105, angle 8 is also 105 because it is a vertical angle to angle 5. Notice that they are across from each other as lines T and Q intersect. So vertical angles are congruent. Now angle 6 is 75 degrees, and there are a couple ways to look at this. One way to look at it is that it's alternate interior angles with angle 3. And since angle 3 is 75, angle 6 is congruent, it is also 75 degrees. You can also say that it is a same side interior angle with angle 4, so they're supplementary. You can also say they're in linear pair with 5 or 8, so therefore it's 75 degrees. Finally, angle 7 is 75 degrees because it is corresponding angles with angle 3. So if I use purple here, here's angle 3, angle 7, corresponding angles are congruent. So you'll notice there are different ways to approach a problem like this. There are different possible explanations. As long as it's reasonable, you'll get credit. There's no single right answer. Example 2a, we're going to try to find the value of x. So you see that the x is an angle x plus 5. So how do we do this? Well, let's figure out what angle 4 is. Angle 4 is 115 degrees because it is a vertical angle to the original 115 degree angle. Notice that we have a transversal and that A and B, the lines A and B, are parallel based on the little arrow, the red arrow. So vertical angles are congruent. So angle 4 is 115 degrees. Let's mark that down. Finally, the other angle, the angle that's missing, the x plus 5, is a consecutive interior angle with angle 4. Now, if you notice, the x plus 5 angle is acute. The 115 degree angle is obviously obtuse, so they have to be supplementary. So same side or consecutive interior angles when a transversal intersects two parallel lines are supplementary. So that means x plus 5 has to equal 180 minus 115, or 65 degrees. So if you wrote x plus 5 has to equal 65, that would be totally fine. So you end up with x equals 60 degrees. Okay, so x is 60. Let's go to example 2b. Same type of problem. We have a 2x, we have a 120. Likewise, the angle above the 120 degrees is 60 degrees by the linear pair postulate. So there's 60. And the 2x angle has to be equal to 60 because those two angles are alternate interior angles. Again, notice that A and B are parallel lines. So that means 2x equals 60, which means x equals 30. Now you'll notice that there are a couple other ways to do this. You can say, well, this angle here is 120, and 2x and 120 are supplementary because they're consecutive interior angles, so 2x would have to equal 60 also. So there are different ways to approach these problems. Example 3, again, we're looking for the value of the variable. It's the value of x. So here we have a 136 degree angle, and we have lines C and D parallel and a transversal intersecting them both. So the rules that we just learned apply. So we know the measure of angle 1 has to be 180 minus 136 because it is a linear pair with a 136 degree angle. So 180 minus 136 is 44 degrees. Now you might wonder, well, how is that 44 degree angle and that 7x plus 9 angle related? Well, they are alternate exterior angles. So remember, alternate exterior angles when you have a transversal intersecting two parallel lines are congruent. So you would basically make 44 equal to the 7x plus 9, and you'll solve for x. So 7x plus 9 equals 44. You'll subtract 9 from both sides, and you end up with 7x equals 35. Divide both sides by 7, and you see that x is equal to 5. If you want to try this one, go ahead on your own. Otherwise, you can just listen to me go over it. Find the value of y. So the question is, how are these two angles related? The 6y minus 3 and the 129-degree angle? Well, they are alternate exterior angles, parallel lines intersected by transversal on opposite sides of the two parallel lines on opposite sides of the transversal. So they are congruent. So 6y minus 3 has to equal 129. So now we're going to solve for y. Add 3 to both sides. You get 6y equals 132. Divide both sides by 6, and you get y is equal to 22. All right, so now we're going to do a proof. We're going to try to prove the alternate interior angles theorem. So you have a diagram. You have given P is parallel to Q, and you can tell by the little red arrows that they're parallel. We're going to try to prove angle 1 is congruent to angle 2. So the first thing is the given statement. So statement 1 is P is parallel to Q. Remember that little symbol that looks like a pair of skis? That means lines are parallel. Given. Statement 2. That angle 1 and angle 3 are congruent. How are angles 1 and 3 related? Well, they are corresponding. The reason is the corresponding angles theorem. You can abbreviate angles with a symbol. You can abbreviate corresponding with corresp, and that's fine. Statement 3, angle 3 is congruent to angle 2. How are those two angles related? If you look at the diagram, how are 2 and 3 related? Well, you can see they are vertical angles. As you know, vertical angles are congruent, so that is reason number 3. So now you have angle 1 congruent to angle 3, and you have angle 3 congruent to angle 2. The final step is to show 1 is congruent to angle 2. How are they congruent? By the transitive property of congruence. So you'll see that angles 1 and angles 2 are both congruent to angle 3, so therefore they have to be congruent to each other by the transitive property of congruence. So that's section 10.2. If you have any questions, post on Google Classroom, send me an email, or if and when I do a Google Meet or Hangout or Zoom, you can jump on and ask me questions then.